This video is over textbook pages 64 through 67. For number 13, it says the equation and table show what two boys pay for gym fees. Compare the rate of change and initial value for each function. So starting with Alfredo, which is the table, to find the rate of change, we want to see what we're counting by. 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. Going across the bottom, 20 plus 10 is 30, 30 plus 10 is 40, 40 plus 10 is 50. We set up our fraction as a change in y over a change in x. The x value is the first column months, the y value is the second row cost, so our fraction is 10 over 1. 10 divided by 1 is 10. Alfredo pays $10 per month. For his initial value, we look at what number is paired up with 0. 0 is paired up with the number 20, and so he has to pay a $20 membership fee up front. If we were to write his equation, it would be y equals 10x plus 20. Now for Alex, the equation C equals 25 plus 10m, and it tells us that C is the total cost in dollars and m is the number of months. Even though that equation is written differently from how we're used to seeing it, y equals mx plus b, we can rewrite it. C is our y value. 25 is by itself, so that's the plus b value at the end. And the 10m, even though m and x always go together, 10m, $10 per month. So picking out the rate of change, it is also $10 per month. But Alex has a $25 membership fee that he has to pay first. So when we are comparing the two, they have the same rate of change. They both have a rate of change of $10 per month, but Alex has a greater initial value. Alex pays $25 up front. Alfredo only pays $20 up front. Alex's is greater. For the next problem, it says Roy wants to buy a new wireless phone for $200. Two stores offer different payment options. Which plan has a greater initial value and which phone will be paid for at a faster rate? So if we're buying the phone for $200, okay, we're going to use this information to help us with our graph and our table for store A and store B. So for store A, to find our rate of change, we're going to take our points that we can read clearly. We have to go down 125 to 100, so we're going down 25 and we're going over 1 week. So our rate of change is going to be our rise over the run, the negative 25 over 1, which we can simplify into a negative 25. He is paying $25 each week. For the initial value, letter B, even though the graph starts here at 150, we know that the phone costs $200. So he paid $50 up front. He paid $50 first before making his $25 payments each week. His equation, if we were to write one, would be y equals negative 25x plus 50. Now for store B, it says pay $50 at the time of purchase and pay $20 per week until the phone is paid for. So the $20 per week is our key for our rate of change. So we can write that as our equation, y equals negative 20x. It's negative because he is paying money. He's spending it, so it's going down, negative 20x. Our initial value is the $50 that he pays up front. the $50 charge, the $50 fee that he has to pay first. That is our initial value. So the question asks, which plan has a greater initial value? Well, they actually have the same initial value. Both plans make them pay $50 first before starting the weekly payments. So they have the same initial value. Second question, which phone will be paid for at a faster rate? Store A will be paid for faster because 25 is more than 20. 25 is a faster rate than $20 per week. So store A will be paid for at a faster rate. For our next problem, it says which statement about these equations is true? So for equation A, we have y equals 3x plus 4. Our rate of change is our mx value that always goes together, that's 3. And our initial value is the plus b at the end, which is 4. For equation B, our rate of change is our mx value that goes together, that's 5. And our initial value is the plus b at the end, which is 2. So looking at our answer choices, it says equation A has a greater rate of change. That is not true. 3 is not greater than 5. Letter B, equation A has a greater initial value. That statement is true. 4 is greater than 2. Letter C, equation B has a greater initial value. This is not true because 2 is less than 4. And the last one, both equations have the same initial value. This is also not true because 4 and 2 are not equal. It says that Ben chose C as the correct answer. How did he get that answer? So letter C was that equation B has a greater initial value. It doesn't have a greater initial value, but equation B has a greater rate of change. So we can go ahead and put that down. Equation B has a greater rate of change. 5 is greater than 3. Ben confused which number was the rate of change and which was the initial value. He mixed them up. He thought the 5 was the initial value. For this problem, we have a graph, and then it says which equation represents a function with a rate of change that is less than the rate of change of the function shown in the graph. Select all that apply. So if we're talking about rate of change, to find the rate of change of a graph, we want to pick out 2 points that we can read clearly. I can read this point here at 2 very clearly, and I can read this point here very clearly. So when we are counting, we count up 1, 2, 3. So we're going up 3, and we're going over 1, 2. We set up our rate of change as a fraction, the change in y over the change in x, the rise over the run, which would be 3 over 2. 3 over 2 is the same thing as 1.5. Should you want to write it as a decimal. So now we're going to compare that to the rates of change in all the other problems below. Remember, the rate of change is the letter m. So in our equation, y equals mx plus b, you're going to pull out the m value. In our first equation, m is going to be 2. 2 is greater than 1.5. A is a correct answer. For equation B, we have y equals 5 over 3x plus 1. Our m is going to be 5 over 3. 5 over 3, if you set up a division problem, 3 can go into 5 one time. Subtraction, we get 2. Add a 0 and bring it down. 3 can go into 20 6 times to get 18. We end up with 1.6 repeating. 1.6 repeating is greater than 1.5. For letter C in the equation, y equals 3 over 2x minus 1, m is our fraction, 3 over 2. Even though they're the same, the question asks which is less than the rate of change. So we are not going to pick that one because it is the same, it's not less. For letter D, we don't have an m value in the front, so we know that that's an understood 1. Our rate of change is 1, which is less than 1.5, so D is a correct answer. And for letter E, when you have a fraction like this, this equation is really y equals 1/2 x plus 5. There's a 1 right next to the x, and so that fraction is 1 over 2. 1 over 2 is less than 1.5, and so E is a correct answer. For the next problem, it says Samantha begins her road trip with 30 gallons of gasoline in the tank of her van. Her van gets 25 miles to the gallon. Let y represent the number of gallons of gasoline in the tank after x miles of travel. So when we want to set it up, we know that 25 miles per gallon is our rate of change. So that's going to be letter M. And 30 is going to be our initial value. So when we're setting up our equation, our correct equation is going to be y equals 30 minus x over 25. Now let's talk about y. Even though it's written backwards, we would normally put that plus b value, that plus 30 at the end. That's fine, it can be switched. Now, the reason it's a fraction, we have a negative 1 over 25x, is because we are driving. We have less and less gallons in the gas tank. We're using the gallons in the gas. So we can go 1 gallon, and that's 25 miles. And so that's how it's being spent. We're going to use 1 gallon, it's negative, and we're going to go 25 miles, 1 over 25. For the second one, it says Evan has a cell phone plan that costs $30 per month and 25 cents per minute of cell phone use. Let y represent the monthly cost of the cell phone service after x minutes of phone use. So our 25 cents per minute is our rate of change, letter M, and our $30 is our initial value. You pay the $30 first and then 25 cents per minute. We would set up the equation as y equals mx plus b. So that would mean we'd have y equals 0.25x plus the 30, which is going to be, even though they've written it backwards, the y equals 30 plus 0.25x. Even though they're written backwards, they're the same equation. For our next problem, we have 2 rates for homework help services are shown below. We have homework SOS, which is a graph, and homework Lifeline, which is in the blue box. The question asks which service has a greater rate of change, which has a greater initial value. So let's start with the first question. Which one has the greater rate of change? To find the rate of change for the graph, we want to pick our points that we can read clearly and make our fraction as a change in y over the change in x, the rise over the run. So if we start with our point, we go up 15 to 20. So even though it's only 1 square, it's really 5 units. 15 to 20 is 5. Going sideways, we're going from 10 to 20 minutes. So that's going 10. Even though it's only 1 square, it's going 10 across. And so our rise over our run, our fraction, is going to be 5 over 10. 5 over 10 is equal to 1/2, or you could say 0.5. And because we're dealing with money, we can say 50 cents. So homework SOS has a rate of change of 50 cents per minute. The initial value is where the graph starts. The graph starts down here at 10, and so that is our initial value. There's a $10 fee first, and then 50 cents per minute. For homework Lifeline, we're going to use the table of values that it gives us. It says that it's going to pay $25 to set up an account with our service, and then pay 40 cents for each minute of homework assistance that you receive. The 40 cents per minute, that's our key word, is our rate of change. Our initial value is the $25 fee that we pay up front. Now, to answer the questions, which one has a greater rate of change? Homework SOS has a greater rate of change. The second question asks which has a greater initial value. Homework Lifeline has a greater initial value. For Part B, we're still talking about Homework SOS and Homework Lifeline, and the question asks what would be the total cost for setting up an account and receiving 90 minutes of homework assistance at each company. So we're going to use the information that we found earlier. For Homework SOS, we found that it costs 50 cents per minute. So when we're solving it for 90 minutes times our cost, 50 cents per minute, that's going to be a total of $45. $45 plus our initial value, our $10 fee, brings us to a total of $55. For Homework Lifeline, we're going to use our rate of change for 40 cents per minute. And again, we're getting 90 minutes of service, so we're going to multiply the 90 minutes times the 40 cents per minute cost to get a total of $36. But for that one, we have to pay the $25 fee. So the 36 plus the $25 fee brings our total to $61. So for Homework SOS, it's going to cost $55. For Homework Lifeline, it's going to cost $61.